We're talking about carbohydrates today. This is our last segment on carbohydrates, and it's titled Fun Facts About Sugars in Water. Yay! Monosaccharides and disaccharides are polar. So what does polar mean? Well, if you look at the poles of the Earth, you've got a North Pole and a South Pole. And so maybe that will remind you of magnets. You can think these things are different. So for example, water, if you remember water, it's H2O. So that means we have two H's and an O. And if you remember, this thing is bigger, and so the electrons are more likely to spend time over here, and electrons are negative, so this side is partially negative, and this side is partially positive because those negative electrons don't spend as much time here. And so that's what this is saying. Monosaccharides, the littlest sugars, they look like this maybe, and disaccharides, which would have just another one of these added on. These things are polar, just like water is polar. And so the reason that they're polar is that these OHs are bent. And so when you look at sugar, you see an O with an H. It doesn't necessarily, you would look at that and you would say, oh, that's really polar. But the way it looks, here's a carbon, and here's how it really works. Here's your carbon. So I'm trying to recreate this. It's bound to an oxygen. Pretend I drew that straight. Now the H doesn't go straight out from there. It's bent. And then the rest of the molecule would be attached to this carbon. So that carbon is attached to the O, etc. So for each of these OHs, this one, this one, this one, this one, and this one, they're all bent. And so that shape should remind you of water because water is the same shape. So there's an O with an H. And then this one, instead of going up to a carbon, this one will go up to a water. And so because this is polar, with the electrons more over here than over here, same thing with this. The electrons spend more time here and less time here. So you have a partial negative charge over at the O and a partial positive charge by the H. So these simple sugars are polar just like water is polar. And so if you look at a sugar molecule, you've got all these positive charges and negative charges. So here's the oxygen, and that's going to be partially negative, and the hydrogen is partially positive. So you've got a whole bunch of these things. So the idea is, what do you think this stuff does in water? So water is polar too. So here's a picture of water. You've got negatives. This side is partially negative. That side's partially positive. I think, yep, I've got that coming out. These really, I think I have another positive too. Good. These things really should be a partial charge. So if you want to write it right, you really should have a parentheses around these to show that it's a partial charge. And that would be the same thing here. I would really draw a partial around here, but good enough. So the negative part of water, this part, is attracted to the positive part of sugar. And so the negative part here is attracted to, whoops, this positive part. This positive part would be attracted to the negative part. And the positive part of water is attracted to the negative part of sugar. So here's sugar, and here's how the water molecules line up. The positive side will be attracted to the negative side here. Negative side here will be attracted to the positive side here. Therefore, simple sugars dissolve easily in water. So if you have a cup of coffee and you put a teaspoon of sugar in it and mix it around, it's not going to separate out into a layer on the top like oil would with water. It's going to mix right in and your whole coffee should be nice and sweet. Simple sugars are hydrophilic or water-loving. So hydrophobic means to hate water. Hydrophilic means to love water. And so sugars mix with water really easily. The OH groups make them water soluble. So here's an OH group. And of course water has the OH also. Notice how they mix up with water, but they do not break any of their bonds. So that's important too. The oxygen and hydrogen bond here doesn't break, but they do mix with water. So in class we have an organizer to work on, and you can get that on It's Learning. And it wants me to quit. Gonna cry again. There we go. Quiz time. Animals store carbohydrates for energy in the form of. So this one is plants, and that's plants. So now we're looking at these two. The way to store energy is glycogen. Plants store carbohydrates. Well, this is for animals. That's for animals and fungi. So if we're looking at energy, it's going to be starch because cellulose it is for plants, but it's not the way you store energy. The structural carbohydrate for plants is cellulose. These, again, would not be for plants, and this one's the one for energy. To us, animals, cellulose is used for undigestible fiber. So another name for that is roughage, and you use that to keep your colon or your large intestine healthy. The structural carbohydrate for fungi and crustaceans, things like crayfish, and also for insects, is chitin. It's the carbohydrate that has nitrogen in it. Chitin, oops, I shouldn't have said that, should I? Chitin is different from other carbs because it also contains nitrogen. And that's it. Say goodbye, William.
Bye.
Because I thought you were so cute.